already passed all of the 3 arithmetic proficiency quizzes that are out of your hair. Some of you have gone and done just the first one, but we want to be sure and get down. The first one is due this Friday, right? And let's be sure and do that. Questions from the quiz that anybody has they want to ask. Figured it out. If you missed any, you know what's. Does anybody want to ask about any of the first one? The first ones, they're in different orders. So, what was the nature of the?
I think it had to do with the diagonal perpendicular lines.
Diagonals perpendicular. Okay. Which of the quadrilaterals have perpendicular diagonals? Are we talking about perpendicular bisectors or just perpendicular?
Perpendicular.
Just perpendicular. Okay, which ones would that be? Heights, what?
Squares.
Squares. And what?
Rhombus.
Rhombus. Any others? Well, if every rhombus is, then squares have to, right? Because all squares are rhombuses. Okay? What are some important takeaways from that quadrilateral characteristics unit that you think you can apply in your classrooms? That topic is typically not taught in high school. It's taught in elementary school, right? Anybody have any takeaways or things that they want to? I've got one. What if you have this figure and you ask your students to identify it, and your student says, that's a rectangle. There are so many elementary teachers that say, no, that's not a rectangle, that's a square. But every square is a rectangle by definition, because what's the definition of a rectangle? Parallelogram. That's, well, we're talking about all kinds of characteristics. Opposite sides are congruent. Angles are all 90 degrees. You could talk about how diagonals are congruent. There's all these characteristics, but what's our definition of a rectangle? Dr. Abby?
An equiangular. I don't know.
Equiangular.
Equiangular quadrilateral. Parallelogram and quadrilateral.
Yeah. If you drew an equiangular quadrilateral, would that have to be a rectangle? It's a four-sided figure with all, which means it's got 4 angles, right? And if it's equiangular, they're all equal. That means they're each 90. So can anybody draw a quadrilateral with 4 90-degree angles in it that's not a rectangle? Hmm?
The square is a rectangle.
That's so we're deciding that, okay.
That would be adequate. If you want to get a little bit more, you could say an equilateral parallelogram, but I think equilateral quadrilateral would do it. But whatever definition you use for rectangle, it always fits for square. Okay? The only difference is square is a subset of rectangles. So please don't, whatever you do, tell your students, that's not a rectangle. It is. In fact, I think you can almost bet somewhere on your first exam, or second or third or somewhere, we're gonna be, maybe all of them, I'll ask you true or false. Every square is a rectangle. I might have every rectangle is a square. You have to know what you're doing. But every square is a rectangle. Why is it? You need to be able to tell your students, why is it a rectangle?
Because it follows the definition.
It follows the definition.
So I just thought about something kind of interesting for the kite rhombus square. So does everybody remember how I had that big long confusion thing about having a kite that has equal sides and we decided it can't? It's pretty much what a rhombus is. And a rhombus, or squares are rhombuses. And so they end up working out for the, if you want to remember which one has the
Perpendicular. Diagonals?
Diagonals. Yeah, they'll all be in that format. So
Okay.
I don't know. It makes sense to me.
Because we were really close to saying that this might be a kite, right?
But it's not.
And then the definition that I think most people accept is that this pair is the same length and this pair is the same length, but the two pairs aren't
The same.
the same, which would make it a
Rhombus.
rhombus. But that helps you kind of group them together with this characteristic anyway. Okay. One other thing I wanted to talk about, did you find Euler's formula? Did you try drawing other networks? It fits for everyone. The question I want to ask you is why? How did he find it? Anybody trip onto that while they were out there? I'm not going to answer that today, but I want you to think about it. How would he have discovered that? Well, he could have looked at a whole bunch of them and found the edges, the regions, and the nodes or the vertices, and he could have seen a pattern, perhaps. But a little bit later, we'll revisit that idea. Anybody have questions about the networks that they want to ask? Network questions? Yes?
So for some reason, it took me a while to figure out what it was asking for the diameter, but I'm pretty sure I know what it is now. It's just, like, for example, should I draw it up on the board? It's
Sure.
hard to explain.
Sure.
So, so I guess 6 was the diameter, so it'd be 1, 2. Oh, I'm counting these. 1, 2, 3. No?
It'd be 6.
It would be 6. I can't remember how I got 6 now.
It's the longest path possible.
So it's a U-shape.
So yeah, you'd go down
Oh,
one leg
that's
and
it.
back up
1,
the
2,
other.
3, 4, 5, 6. That's how I got it. That's right, right?
Okay?
That's
Yes.
what I'm doing. Okay. That was my question. Thank you.
Let me ask you this. Did I teach you about, what's this kind of network called? A tree. Did I tell you about trees in class? No. Did I tell you about diameters? No. So why would a teacher give students a question that they haven't taught them about?
Didn't teach directly about it.
Hmm?
You didn't teach directly about that type of network, but we did discuss
We did networks in general, yeah?
When we find things on our own, when we discover it for ourselves, it helps us learn it better.
Well, I think that's a possibility. That's not really why I did that, but that works. Yes.
You might do it just to see if your students are willing to come find help if they are struggling, or if they don't know what's going on, if they're willing to go the extra mile.
Okay, I was hoping actually none of you would come for help. But, yeah, that's another, yeah.
Maybe you're talking about it today, and so it's kind of like a review for
A preview.
today.
So many times I will assign things that, in fact, you're going to find that there were some homework questions that we are going to use today. But that's not why I gave you this one either. But that's definitely one of the reasons to put something on an assignment, to help prepare students to get ready for something coming up. Here's the reason. After having taught 23 years in the public schools, my experience is, because I changed textbooks lots of times at both junior high and high school level, and I came across mathematics in the textbooks that I had never been taught before. Ever. And I am going to tell you right now that you will teach less than 5 years, all of you, those of you who go out and actually teach and jump in and teach, within 5 years, all of you will come across mathematics that you have never seen before. And I don't care if you got A's all the way through junior high and high school and went through AP Calculus and AP Statistics your senior year, and you came to BYU Idaho and you took 205 and 206 and Ed 442, the math methods, and got A's in all of them, took 108 and got an A in all of those, you're going to run into mathematics you have never seen before. I know that. What are you going to do when you run into it? Well, they didn't teach me that in 205 and 206. We'll just skip that. No, it might be on the Common Core Smarter Balance Assessment. So what are you going to do?
Figure it out.
You're going to learn it. That's right. Because if you got to teach it, you need to understand it. And how will you learn it?
Ask coworkers.
Co-workers are excellent sources. Go to your teacher next door who's been teaching maybe in that book for a while and ask. What else?
Researching it, like
Researching.
online.
Go online. Google's a good friend. Wolfram Alpha. Have we talked about Wolfram Alpha in here?
No, it's a happy
It's a nice place. Sometimes you can just read it, and I tried to write that so it was clear, and you had a little bit of confusion,
For some reason,
But-
I've read it 100 times.
but you got it straightened out, and it looks like you've got it. See?
Well, I'm glad you had the examples, because I think that's when I really did it.
Okay. So look at examples and do, yeah. So I think we're all capable of learning. And we're all going to be called upon to do it, so why not give you a little bit of practice now? I didn't throw you clear out in left field. We did talk about networks, and you knew what nodes and edges were. You just never heard of diameters and trees and those kinds of things, right? And for those of you who have had me before, it is not uncommon for me on an exam to ask you questions about things I haven't taught you. But I will give you something like this with some instruction and some examples, and then you'll be given an opportunity to say, well, here's how I can learn. I think that's a goal. That's a goal I have for you, is to have you become self-learners. And therefore, I think I should, that's one of my goals. If I want you to become that, I ought to give you opportunities on homework and assessments to show me that you can do that. So, anyway, some people think it's crazy asking people to do something on a test that they haven't been taught to do. Be watching for it. All right. we've done Euler's, talked about Euler's formula, we've talked about networks, and I would like to jump now to a new topic. Okay. Today we're going to talk about congruence, and in particular, congruence of polygons, and specifically congruent triangles. So let's give you a definition of congruent polygons. Anything in this PowerPoint you do not need to write down because the PowerPoint is available to you on Island. If there are things we talk about and ideas you come up with, or other things that aren't on the PowerPoint, feel free to take notes on them, but you don't need to take notes here. Two polygons are congruent polygons if and only if they have all their corresponding angles congruent and all their corresponding sides congruent. So there's two things that they have to have: sides and angles. For example, if we take a look at this one here, we've got LE, find it, LE is congruent to BO, ET, which is here, is congruent to OG, TS, the segment TS is congruent to the segment GY, the segment SL is congruent to the segment YV. So there's the four pairs of corresponding sides for this quadrilateral. The angles, the corresponding angles, angle L is congruent to angle B, angle E is congruent to angle O, angle T is congruent to angle G, and angle S is congruent to angle Y. What do we mean when we say they're corresponding sides and they're corresponding angles? What would we mean by corresponding? Anybody?
They measure the same angle.
They measure the same angle. Well, go ahead, Shannon.
Isn't there congruent?
In this case, they are, but we could have some quadrilaterals that weren't congruent, and we could still talk about corresponding.
I think of it as if they were like cut out and you put them together, what angles would be in the same place if they fit together?
Okay. Does that make sense? So in order to get this, if we were to cut them out, how would we get one to get on top of the other one? We'd have to flip one of these, right? Does everybody see what she's talking about? Another word for corresponding would be like matching. Matching sides, matching angles, the ones that go with each other. Okay, if we have all pairs of sides and all pairs of angles, then the polygon LETS is congruent to polygon BOGY. By the way, this if and only if means it goes both ways. So I could tell you these 8 things are true, you would know this was true. Or if I could told you this one thing was true, you would know these 8 things are true. It goes both directions. Okay? That definition allows us to go both directions. Now, the same thing applies to triangles, except this time we have 3 pairs of corresponding sides and 3 pairs of corresponding angles. And if all 3 pairs of angles and all 3 pairs of sides are congruent, then the triangles are congruent. Okay? So there's some examples. Do we need to flip this one? What do we need to do? Slide one, right? And then it would be on top of the other ones. Everybody see what we mean by slide? Okay? If that's true, then triangle WHY is congruent to triangle NOT. Huh?
Why not?
What's boogie? And some of you have just noticed something that you can take a so-called boring math topic and spice it up with a little bit of creativity. Okay? You what?
Like saying Jack in class period last, do you remember that?
What?
Said the word Jack. It made me laugh. You guys don't remember that?
Can't remember. Why did it make you laugh?
Because you're like, it doesn't mean jack. Oh.
Right. Anyway, a building contractor has just assembled two massive triangular trusses. Does anybody know what a truss is? Yes? Some of you do? Guys, go out and build. The truss business is a big business, and there are businesses that all they do is build trusses. What are they? It's the thing that goes on top of the walls and under the roofs of buildings. So you'll see them like this, and they go like that, and then they have things that come down like this, and there are braces and these kind of, anyway, there's, and they're just this wide, but they could be, and then they sit them up on there and stand them all up, and anyway, this contractor has just assembled two massive triangular trusses that will support the roof in a recreation hall. Before the crane hoists them into place, she wants to verify that the two triangular trusses are identical. Why would she want to know that?
So that your roof sits flush.
So that the roof is what?
It's flat.
Is flat. Right. You don't want a roof that goes like this and undulates, you know, or you want a nice, and in Rexburg you want to make sure that the pitch is sufficient so that snow can come off of it, because if snow gets too deep and doesn't come off, what happens? The load gets too great and it actually collapses, and yeah, that's happened. Okay, according to the definition of congruent polygons, if the three sides and three angles of one triangle are congruent to the corresponding three sides and angles of the other triangle, then the two triangles are congruent. Does this mean that the contractor must measure and compare all 6 parts? What do I mean by 6? The 3 pairs of angles and the 3 pairs of sides before she hoists them up? Or is there a shortcut? There must be a shortcut. It would seem that only a few of the measurements are needed, but how many and which ones? Let's see if we can answer this question. Triangle shortcuts. Wouldn't it be nice if the contractor could measure only one side in each triangle and find they're congruent, and know that the triangles themselves were congruent? In other words, if she knew that one side of this triangle is congruent to one side of another triangle, could she then state that the triangles must be congruent? You're shaking your head. Do you have a counterexample?
I think you have the same side.
Go draw a counterexample for us there.
One of the ones with the same sides, but the corresponding sides.
Okay, so if you were to measure the 2 sides she has marked and found they were the same, that is not enough to guarantee that, obviously, that the 2 triangles are congruent. Does everybody agree? Okay. So, what we're going to call the side shortcut, taking one side of each triangle, is not sufficient. Do you agree? Yes.
If you have the right triangle, isn't it sufficient though? Like if you had like 60, then you could look at it and see that it was the right triangle, couldn't you know that all the other two are going to be 30 and 90?
If I had one side that was the same as the other side, but we knew they were right triangles,
Well, if it was the right triangle, and you could tell, and you only measured one side.
let's say that side is the same as this side, and they're both right triangles. Let's see, I want to... There we go. Those two are the same length. This is a right angle, that's a right angle. Are the 2 triangles congruent?
Nope.
Okay. But you're actually bringing in one more. We're just using one side, and you're saying a side and an angle here. So All right. Well, there's another counterexample. This side right here is congruent to that side, but obviously the two are not congruent. By the way, what is a loose definition for congruent triangles? We have the official mathematical definition, which says all three pairs of sides are congruent to their corresponding sides, and all three pairs of angles of this one are congruent to their corresponding angles. But what is a loose kind of way of thinking about it? And Aubrey kind of gave us a clue. If you can take one end, put it on top of the other one, either through flipping it or sliding it or rotating it, or a combination of those three things, and get one to match right on top of the other, that's kind of a way to think about congruent. If you can do that, then it fits the definition of all those 6 things. Does that make sense? So there's an official definition, and then there's one you just ought to have a gut feel for, and you ought to know that gut feel. All right. What about knowing that one angle of one triangle is congruent to one angle of another triangle? Would that guarantee that the two triangles have to be congruent? You shook your head pretty fast. Have you got a picture of a counterexample you could draw for us? Okay. Are the two angles, do they look like they're the same size about? We're not going to get a protractor out, but she's drawn two triangles that are obviously not congruent, right? They would not match if we slid or rotated or whatever. Okay. So the angle shortcut doesn't appear to be a valid shortcut either. So now that's using one, there's another example of another counterexample of one that doesn't work.